This is the day 2 of the daily DSA series, and today's question is found special triplets, which is the daily problem of today. And in this question, we have been given the array in nums, and a special triplet is defined as a triplet of indices I, j, k, such that I, j, k lies between the range 0 and n, in which n is exclusive and 0 is inclusive, and n is equals to nums of length, and there are two conditions that need to be satisfied. The first one being the first number should be equal to the multiple of second number, and the third number should be the multiple of the second number as well. To be more specific, the multiple of 2. And we have to return the number of special triplets that are in the array. So here is the brute force approach for this question. And here I have just initialized an variable n and declared its value as the length of the nums array. I have declared a long variable named as count, which will be tracking the number of triplets inside uh, the array. And since the question requires that we have to return it in the model of 10 to the power 9 plus 7, we have declared a mod variable which will be containing this value. We would be just returning the non-casted value of this non modulo mod so that the constraints are satisfied. So beginning with the question, the first for loop runs from the range 0 and -2, which is this part of the array, and the second nested loop would be for the j element, which would be running from the next element of I, that is from this part to n minus 1, that is this part would be covered. Similarly, if the satisfied condition are true, like this condition is satisfied, then only it moves for the third nested loop, which is this one, which is a nested loop for the element k that would be running from 2, 8 to 4. This array is covered in this. And it is a very basic code because it is just uh, in enforcement of these conditions into the three nested loops that we have created. If this condition is satisfied, then only it moves to this second condition, which is the third number should be equal to the second multiple of the second number. And in this case, if it satisfies, then it increases or increments the count variable. And after each iteration, we find out every unique uh, special triplet, and at the end, we just return the count of it. So this is a pretty brute force approach. There is a probability that any time limit exceeded error can occur. So here we can see the code works simplifying for smaller numbers in this case, but when I submit it, you can see there is a time limit exceeded. So it works for most of the questions, most of the cases, but it doesn't for some of the long cases like this one. So this is a very inefficient code in that regards, and stay tuned for the most optimized solution of this question. So this right here is the most optimized solution for this problem. What happens in the solution is that create two hash maps, which would be containing the frequencies of the elements inside the array. For example, the left count hash map will be containing all the element frequencies that are present on the left side of the considered element. For example, if the loop right here has its iteration run over the second element, then hash map left count would be storing the frequency of the elements in the left side of this element, and hash map right count would be storing the frequencies of the elements in the right side of this element right here. So this array. So this is the creation of the hash map. Currently they are empty, and when we initiate a count variable with the value 0, which will be counting the number of possible special triplets. And now we'll be populating the right count hash map of this array right here, because we would be traversing from left to right. So the left hash map right now is containing 0 elements, and we would be populating the right count hash map. So the final hash map will be looking something like this, where 8 is equals to 2, 4 is equals to 2, and 2 is equals to 1. And then we will be traversing the array starting from I is equals to 0, that is the first element right here. So for the sake of simplicity, we are storing the ith element inside the num variable. Now, what we would be doing is that we would be removing the element on which we are right now. That is the first element from the right count hash map, so that it doesn't get counted in that iteration, which is logical, right? Because if we are on this element, we want to check what is on the right side of this element. So simply we'll be removing one element from this side. So finally the array will be something like this. The hash map will be something like this. And then if right count dot get num is equals to 0, right count dot remove num. So if right count dot get num is equals to 0, right count dot remove num is equals to 0. So what this does is that if the frequency of the element on which we are right now becomes 0, then there is no use of it inside the hash map. For example, if it was appearing once in this array, the frequency after doing this operation would be 0. So we would simply remove this entry from the hash map, since it is of no use in the future. It would be just a wastage of memory. So which is not the case right now. So let's repopulate it again. Okay. And after this is done, we would be storing the left variable, which would be counting the number of frequencies of the element that we are requiring on the left side of the array. Since the left count hash map is currently empty, it does not contain any elements, so it would be simply returning 0, which is logical because here, if we are on this element, there is nothing on the left side. But on the right side, we can see that there are elements. So we would be checking the criteria if it's satisfied for the right count hash map in this. And what the criteria is that the element on which we are right now, does it have something on the right side of it such that it is the double of the current element, which is the requirement here, nums j into 2. So for the element 8, we will be checking if there exists any element 8 into 2, that is 16 on the right side. So we can simply see that right count currently does not have any 16 inside it. So simply it would be returning 0, and the count element would be counting the simple multiplication of those two and add it inside the currently existing count variable. So in the first iteration, it simply is 0 into 0. So this would be 0. And what we would do in the last is whatever element that we have removed in the beginning of this for loop, we will be adding it inside the left count array. Sorry, left count hash map. So the left count hash map would have the frequency of it as it is equals to 1. Then we would iterate it for the second element. Similarly, for the second element, we can clearly see that the double of 4, that is 8, appears in the left count as well as on the right count, and their frequencies are 1 and 1 in both cases. So the count would be storing left into right plus the current count, which is 0 plus 1 star 1, because there is only one possible combination, that is 8, 4, 3. So it would be storing it inside the count, and similarly left count output num will be commanding the programmer to store the current element, that is 4, inside the left count, and we would be removing. So this loop goes on till the end of the array, and till we get the required count variable. Simply we would be returning it modulo 1 into 10 to the power 9 plus 7 modulo. This is a very simple question in that regards, because it is very simple to understand, and that's it. And the space complexity of this is O of 1, because we have created hash maps which are not that well, the space complexity here is due to the creation of these new hash maps, and on average, since we are iterating over every element inside that, so the space complexity is O of n. The time complexity is O of n, because we are checking for every integer inside the array. So these are the complexities of this code, and yeah, that's it.